Hey everybody, I'm going to try to sketch a picture of what it is we're looking for. Now y'all, the well-known x-axis in algebra, another name for the x-axis is just y equals 0, right? So that helps us to draw a picture of what turns out to be a hyperbola. If y is equal to 0, we're going to get two easy to identify x-intercepts. One will be the square root. Let me just see if I can get this drawn here. Okay, we'll call this point square root of 23, 0. All right, folks. Okay, and then another solution to this, if y is equal to 0, remember y equals 0 is another name for the x-axis, right? Okay, so y is equal to 0, we get plus root 23, and symmetrically just across the way here, we're going to get minus. And probably technically I could get by without writing this down, but I just want to draw a rough sketch of what it is we're seeking here. There's a circle involved here, and we want to find its area. And first blush, you don't think there's enough information given. Okay, so here we go. So the graph has no choice but to go in this direction just based on the nature of this equation. Okay, it doesn't exist. It would have complex solutions between minus root 23 and plus root 23. Okay, and then over here also. Okay, so there's our two branches. Now we're saying that the circle is tangent to both branches of this hyperbola and also to the x-axis, and so that would naturally be right here. And so our circle would look something along these lines here. And y'all, this is very horrible circle. I'm doing my best to convince you that it is a circle. Okay, so there is our circle. Wow. Okay, now y'all notice that I've drawn it underneath, which would say the coordinates or the center right here would just be 0r, okay? Now, if you want to, we can call it 0 negative r. Of course, we're stipulating that r is greater than 0. Okay, so one strike against me already, folks. This is supposed to be a circle, right? But it's going to be tangent to the hyperbola there and there, okay? The cool thing about this problem is we're not going to have to find too much here. It's neat how it works out. Now, so again, this is the equation for the circle. It's translated down r units on the y-axis. And what we do here is we do a very natural thing. This eliminates x. If we subtract the graph of the hyperbola or the equation for the hyperbola from the equation of the circle, you see how the x's eliminate. The x's are going to eliminate, and we end up with this right here. Or here's the subtraction that's actually occurring. Now, y'all, by the way, when you expand right here, you get 2yr and you get r squared twice, and so the r squareds cancel. That's why we just have 2yr right here, right? We have 2yr located right here. All right, and so we subtract. You can subtract equals from equals, right? And then, as I mentioned earlier, the x squared terms eliminate. Okay, the x squared terms eliminate. And you end up with this result right here, which is just a quadratic. This is a quadratic in the variable y. And so we're going to set the discriminant equal to 0 because we just want it to touch at these branch points. We want there to be a single solution to this quadratic equation. It's a single solution, but it corresponds to these two symmetrical branch points. All right, so we set the discriminant equal to 0. And that's what this is. 2r is the coefficient of y. So we do 2r quantity squared. Okay, then this is just the familiar quadratic b squared minus 4ac equals 0. And when you do that and solve for, get everything solved, you get 368. That's pretty cool, folks. And so that means the area of the circle, remember the area of a circle, and yes, this is my circle. God, I'm ashamed to admit it, y'all, but the area of this circle is pi r squared, but you see we just found r squared to be 368. So the answer here is pi times 368, or maybe people would write it 368 pi. 368 pi square units. Okay, that's the area. That's a weird looking pi symbol, isn't it, folks? A little distorted there, but that's the area. And again, this was set up to be a calculus problem. Again, pi r squared being 368 right here, okay? This was originally not this exact problem. It was the HMMT, that's a Harvard MIT tournament they have. They call it the Guts Round 2024 recently. And a lot of the people, Black Pen, Red Pen did this, and he found a way to do it that's slightly different. It involved taking derivatives. Here we never took a derivative. You would think that would be natural. You know, you're talking about tangent lines, but there's a way just to eliminate and get a quadratic in the variable y. And the coefficient is r, which is we want to know what r is, and we can find out what r is by setting the discriminant equal to 0 to ensure that this is just a touch, that the hyperbola just touches this distorted looking circle. This is a circle, I promise. It just touches it. You know, if the discriminant was not equal to 0, say if it was positive, this hyperbola would intersect the circle in a couple of spots over here and a couple of spots over here, something like that, depending on the values, I guess. But anyway, that's all, folks. I liked it a lot. Thank you for viewing.